Welcome to the Northwest Ductless Heat Pump Project's video titled Basic Concepts Used in Calculating Heating and Cooling Requirements. We hope you will stay tuned until the end, where you will be shown links to additional resources and videos to continue your learning. Here we see the roadmap for an HVAC sale, where the salesperson uses a load calculation in their work. It starts with gathering information about the home and the homeowner. In step 2, this information is used to perform a load calculation. And in step 3, the salesperson uses the load calculation to select equipment. Finally, in step 4, they create a proposal for the homeowner to consider. As you can see, the heating and cooling load calculation is an essential step in the entire process. The primary goal of this presentation is to introduce you to the factors involved in heating and cooling load calculation. While we don't teach you how to use a specific software, the information in this presentation will be essential when you perform any kind of load calculation in the future. The first key concept to learn is the building envelope. The building envelope is made of surfaces like walls, ceilings, floors, foundations, windows, and doors. These surfaces form the building envelope when they separate the indoor or conditioned space from the outdoors or unconditioned space. Let's cover the next key concept, which involves heat loss and heat gain through the building envelope. Heat is lost through the building envelope in the winter. Heat is gained through the building envelope in the summer. We use heating equipment to replace the heat lost through the building envelope in the winter. Conversely, in the summer, air conditioning is used to remove the heat gained through the building envelope. Of course, HVAC equipment must be properly sized in order to do this work. It is possible to calculate the heat loss and heat gain through the building envelope, but many material factors are taken into account. This includes materials like insulation, air sealing, windows, and doors. Let's move on from key concepts and into some basic concepts. The first is, different construction materials pass heat through at different rates. This means that windows lose and gain heat differently than walls, and doors lose and gain heat differently than windows, and so on. The reason for this is because each are made from different materials, and they're constructed differently too. When we calculate heat loss and heat gain in our mission to properly select HVAC equipment, we use a different factor for a square foot of window than we use for a square foot of wall, and so on. The second basic concept is closely tied to the first. Different types of window and door materials will lose and gain heat differently. The rate at which heat moves through a material is defined by its heat transfer rate, or U value. The lower the U value, the slower heat moves through it. Compare the difference between these three windows. By adding more layers of glass and filling the space between them with an inert gas like argon, we achieve greater improvements against heat loss or heat gain. The third basic concept concerns insulation, which is a material used to fill air cavities in walls, ceilings, floors, and in other places in the home. Insulation's resistance to heat transfer is defined by its R value. The higher the R value, the better, indicating a greater insulating effect. A little information about ratings. Notice in this illustration, the higher the R value, or resistance to heat transfer, the lower the U value, or rate of heat transfer. The fourth concept concerns differences in heat loss and heat gain between walls and ceilings. Ceilings just below a roof or attic space require more insulation than walls to control heat loss and heat gain. Even if there is no attic, a flat roof directly exposed to sunlight can gain a great deal of heat. To reduce the amount of heat lost in winter and gained in the summer, Insulation is very important. The more insulation, the less heat gain or heat loss you will have. Interesting fact, if a ceiling has an occupied space above, for example, another conditioned room in the house, or even another apartment, there is no heat loss or heat gain to calculate. The fifth concept involves floors. Typically, floors can be the second most important factor behind ceilings that contributes to heat loss and heat gain. However, the amount of heat lost or gained depends on what is going on below the floor. For example, if the floor has an occupied space below, which is heated and cooled, there is no heat loss or heat gain occurring. If the space below a floor is unconditioned, either a crawl space or unconditioned basement, heat loss and heat gain will occur between the floors. After we consider what is located below our floor, we consider the level of insulation. And just like with walls and attics, more insulation is better. The sixth factor to consider is the amount of air that passes between the inside and the outside of the home. We call air that leaves the home leakage, while air entering the home is called infiltration. Less leakage or infiltration is better. However, it should be noted that leakage and infiltration are nearly impossible to eliminate, and experts agree that some limited amount is desirable to ensure that the air in the home stays fresh and healthy. Some homes can have so much leakage and infiltration that they are called drafty, and this is undesirable. Air leakage and infiltration are prevented by caulking and air sealing seams and gaps in the home with caulking or other weatherizing material. Air leakage and infiltration is measured in air changes per hour, with a lower number being desirable. For concept number 7, the location of the ductwork is the primary factor, and the condition of the ductwork an important secondary factor. We are primarily concerned with the ductwork's location. If it is located in an unconditioned attic, basement, garage, or crawl space, it will lose heat in the winter and gain heat in the summer. However, if ductwork is located within the conditioned living space, such as within walls or ceilings, we do not consider ductwork to be a source of heat loss or heat gain. Our secondary concern with ductwork is its condition. Poorly constructed or damaged ductwork can be a source of air leakage and infiltration, as well as a place for heat energy to be lost or gained. To prevent unwanted air leakage and infiltration, ductwork can be repaired and sealed, and then finally insulated. This combination of air sealing and insulation will prevent the majority of heat loss and gain, but will not entirely eliminate it. Concept number 8 involves the influence of sunlight shining directly on the structure. Sunlight causes heat gain, which can be desirable in the winter, but undesirable in the summer. During the summer months, sunlight shining directly on the structure can be a major source of unwanted heat gain. In particular, the southern and western facing sides of the structure experience the most heat gain from sunlight. In the winter, sunlight can be a desirable factor in adding heat to the structure. The gain of heat in the winter months can reduce the amount of supplemental heating that is required, which lowers operating costs and reduces energy consumption. We hope the concepts you just learned will be put to good use. In fact, all of the concepts will be applied when you perform a heating load calculation. There are many software programs available that can assist you in performing accurate load calculations. Recently, the Northwest Energy Efficiency Alliance rolled out a free software program called HVAC Sizing Tool. The tool is a free web-based program offered by utilities to help installers do complete load calculations. To create your account, go to www.hvacsizingtool.com. If you are installing ductless heat pumps, You can put the concepts you learned today to use in another way thanks to the quick and easy load calculation method offered by the Northwest Ductless Heat Pump Project. The quick and easy load calculation method is perfect for ductless heat pump applications using the displacement method. This is where the existing heating source is retained for use as needed, and the ductless heat pump provides the majority of the home's heating and cooling needs. The quick and easy load calculation method is also perfect for single room applications too. To learn how to use the quick and easy load calculation method for displacement applications, check out the video dedicated to the method. In this video, we walk you through displacement applications and how to calculate a load using the table of load factors we showed you in the previous slide. We hope you check it out. We hope this presentation has given you a strong foundation for making load calculations. For more great contractor resources, visit goingductless.com or HVACsizingtool.com. Thank you for watching.